Okay, so the other part of what we're looking at here in our eighth unit, not chapter 9, but our eighth unit, this comes out of chapter 9 in a certain book, so don't let that throw you, are sampling distributions, but now we're talking about means. So what we should have learned, where this is going back to, if you think about when we did the means of the fishing tournament and the basketball teams, that according to the central limit theorem, sample means will be approximately normally distributed uh, for any distribution, right? You go back and you think about the fishing tournament, the original data, was very, very skewed, and the basketball data, right? The fishing was very skewed, and the basketball teams, right? I think there were two different peaks. But the thing was, when we took samples from those distributions, we ended up doing a bunch of X bars, right? Those X bars ended up being, normally distributed, right? They started to take on this shape, and even from the basketball team, they ended up taking the shape. Now, the basketball thing, we did end up with one kind of funky distribution, but that's when we did sample size 2. When we did bigger samples, we ended up, when we did X bars, right, we did a bunch of averages, right? We're taking samples and we're averaging the samples. The central limit theorem again told us that those sample averages will be normally distributed, which for us, again, we're going to be able to play this game where, well, since they're normally distributed, we're going to be able to use normal CDF again. Quick review, right? Just notation, sample proportion was p hat versus the population was p. Well, the new thing for us now, a sample mean, all those samples we did was x bar. And we're going to use x bar. The symbol for population mean is mu, right? So for us, the x bars will be normally distributed, right, around the true mean. And then here's your new standard deviation. You do sigma divided by the square root of n. Now remember, p hats, they were also normally distributed, but they were normally distributed around the true p, and then we did a standard deviation of pq over n. That gave us our mean and standard deviation for the normal CDF, and that also helped us do the curve correctly. So the one thing we need to realize here, as long as we take big samples, right? Small samples, especially if you let me go back. Remember when we did sample size 2 with the basketball, we ended up with that funky, there was a little peak and then kind of a big peak in the middle, and then there's a third little peak kind of on the end, right? When we did the small sample. What this is telling us is that we want big samples. And here's that randomness again, right? We want to make sure we're taking random samples. We need to realize that the reason we're using a normal distribution is because we are taking samples, right? That means that if we're just looking at the probabilities, say we go back to the boat example, that one boat would be a certain value, okay? Go back, remember the boat distribution. You might not remember this, but it was pretty skewed. We can't use this to find the probability of one boat, but if we take a sample, the samples will be normal. Not the distribution itself, the samples, the X bars will be normal. So again, if we're looking for a single boat, we'd basically just have to go in there and find that boat, one out of however many boats were in the tournament. In this example, and most of the examples we're going to do, we take samples and then we look at the likelihood of getting a certain average for that particular sample size, right? And really, I kind of want to squeeze sample size in. So the conditions for sampling means, well, here's that large sample, right? Typically more than 30. Some texts will say n has to be greater than 20. Some will say greater than 25. I mean, we saw it starting being normal. Think back about the fishing tournament and the basketball team. We saw it start to play out when n equals 5 or n equals 10. So if we're doing bigger samples, that's just going to increase the likelihood of us seeing a normal distribution. So Most books will tell you n has to be greater than 30, but some texts, some things you'll see online, you'll see these numbers too. Basically, we just want to make sure we're taking a big sample. Now, the one exception to that, you can take small samples if it's from a normal distribution. So this is just read the question carefully. Sometimes it'll say, hey, this data is normally distributed, blah, blah, blah. It seems like it's saying it in passing, but you'll see that play out. And then the other magic one, make sure that your data is taken randomly, right? We want to make sure that we're collecting the data properly. So one quick example to walk through here on that worksheet 9.3. The first question, according to the article about this house finch, the average song duration for the population of house finches, there it is, population mean is 1.5 minutes. So all of a sudden we got population mean is 1.5 minutes with a standard deviation of 0.9. We take a random sample, right? There's SRS, 25. How likely is it the average song duration of the sample? So really, X bar here, 1.7. How likely? There's the probability. So we're looking for the probability that the average song duration of the sample. Well, we're looking for the average of the sample. We've got a way to show what that is. That's X bar will be greater than 1.7. Right? That's what we're after. So here we go again. Check the conditions. It said it was randomly selected. Never said that it was for a normal population, but 25 it's going to be a big enough. So we have a large sample, large enough. So the distribution, right? We're just using our formula, right? This is sigma over the square root of n. And that'll give us that the X bars, right? If we did a bunch of samples, I don't want to do that anymore because it would take a long time. We don't want to do sampling or simulation anymore. We're going to use this formula now. So the X bars are normally distributed around the true mean, and then the standard deviation of 0.2. Right? That's what this says, but it says it a lot quicker using kind of the Mathanese. So if we drew a normal curve, right, the center of that curve is 1.5, and then we just go 0.2 along the way, and we're looking for, again, we want the probability that our X bar is greater than 1.7. So there it is. So for us, right, we've kind of shown all the appropriate steps so far. If you want to go ahead and do your normal CDF, right, we're going from 1.7 to infinity. We're centered at 1.5. And then our standard deviation, I think, was 0.2. And give me just a second. We're going from 1.7. So that probability, 159. So there's a 15.9% chance, a sample of 25 finches has an average song length over 1.7 minutes. So that's a pretty good chance, we're well above that 0.05 cutoff.